Example 2, 2x minus y plus 3z equals 9, x plus 2y plus z equals 8, and x minus 2y plus z is equal to 0. Again, you have to make a decision. If we're going to use this elimination technique, we have to get rid of something. What do you think we should get rid of?
Y.
Y looks good to me. What I look for is this. I can get rid of one of them easy. If I can get rid of one easy, that's just a bonus. Just changing the signs gets rid of x pretty easily. Just changing the signs gets rid of z pretty easily. But these are already set up to get rid of y. All right, so if we get rid of y, obviously I'm going to pick these two, right? So if I pick those two, I'm going to get 2x, 2y minus 2y cancels, plus 2z is equal to 8. The other one I want to get rid of, let's go with the top in the middle. I picked these because the signs are different. This, of course, has to be doubled. So going back to this whole, I think you can handle this cutting the corner step. If I double this equation and I combine it together with this equation, all right, again, I got rid of y the first time, I've got to get rid of y the second time. You have to get rid of the same variable both times. If you get rid of y in one and x in another, you're still going to have 3 variables. So if I do this, I'm grouping these two together and I'm doubling the top equation. So 2 times 2x is 4x, added to x makes 5x. 2 times negative y is negative 2y, combined with positive 2y cancels. 2 times 3z is 6z, plus 1z is 7z. And 2 times 9 is 18, plus 8 is 26. So 5x plus 7z is equal to 26. So, just like that, we had 3 variables. I've gotten rid of y twice, now I've got 2 variables. This system of equations is going to tell me the values of x and z. Once I know what x and z both equal, I can come up here and figure out what y equals. Okay, that's the technique each time. Go from a system of 3 to a system of 2, find those 2 answers, then go back and find the third. So, elimination again, what do you want to do?
Solve for x.
Solve for x. Alright, so get rid of z. Is that what you want to do, or do you want to get rid of x?
Get rid of x.
Get rid of x, alright, doesn't matter. Alright, we'll get rid of x. So, if I'm going to get rid of x, 2x and 5x can both become 10x, right? Right? That's pretty easy. So, I'm going to multiply the top equation times 5, and I'm going to multiply the bottom equation times negative 2. Okay, now this whole cutting corner step gets a little bit more complicated if you have to multiply 2 things together. If you can handle it, fine. If not, again, the whole thing I'm concerned about is cramming all this work into a little box. All right. If you want to go maybe to a separate sheet of paper to work these out and come back and put down what it is, if you can't handle the shortcut, that's fine. But again, if you have to do this and you rewrite 2 equations, I just took up 2 more lines on your paper. All of a sudden, the work's getting really cramped in there. So here's me doing the shortcut. 10x minus 10x cancels. 10z minus 14z makes negative 4z. 40 minus 52 makes negative 12. Okay. If you have enough short-term memory ability to keep 2 numbers in your head through a multiplication process, then add them up, I'm not trying to knock on anybody, but some people short-term memory, they can hold a lot, some can't hold as much. It has nothing to do with intelligence, it just has to do with how your short-term memory works. That's what's going on here. So 40 minus 52 is negative 12, 10 minus 14 is negative 4z, 10x minus 10x cancels. That's all I'm doing there is I'm doing the multiplications, then I'm doing the addition or subtraction. There's minus signs, plus signs, so all of a sudden you got to, should I add, should I subtract? If you have to actually visually see that stuff written down, 10x plus 10z is equal to 40. Negative 10x minus 14z is equal to negative 52. You have to actually see it written down so to see opposite sign subtract, 14 is bigger negative, opposite sign subtract, 52 is bigger negative, fine. But again, maybe this is a scratch sheet of paper, then you transfer the answer over here. Again, I'm just trying to conserve some paper here so that you don't have to cram all your work into a little space. All right, once we get negative 4z is equal to negative 12, we know that z would have to equal positive 3. All right, divide both sides by negative 4, you get a positive 3. Once I know what z is, I can go back to either one of these 2 equations. I'm going to go to the blue one, it looks friendlier. And I know that 2x plus 2z is equal to 8. And notice 2 times 3 is equal to 6. Move the 6 over, I get 2x is equal to 2. Divide by 2, I get x is equal to 1. Just just like that, I have x and z figured out. Then I go back to any one of the three equations up top. I'm going to go to this one. Everything's plus. I like plus. It's my favorite. So there's minuses in the other two. So that's how I decided to use that one. Any one of the three will work though, so don't feel like you have to use that one. X is 1. Y we don't know yet, so it stays 2y plus z, which is 3, is equal to 8. 1 and 3 make 4. So 2y is equal to 4. So divide by 2, we get y is equal to 2. So you got x, y, and z, and again, x equals y equals z equals comes into an order triple, x first, y second, z third. Some of you still are really fighting me on this, being really stubborn. I don't want to write it down like this. I want to leave it just like this over here on my paper. You can obviously figure out that I meant this to be the answer. Write your answer like that. Let's start deducting points if you don't start writing the answer like I want to be written. So that's it. It's the same problems they were before. Again, we have this elimination technique that gets us to this point. I think you'd prefer that personally, but up till now the other one was so easy to go with substitution, we did it that way. Now it's a little bit uglier to do substitution. This is much more efficient.